Okay, so here we are back at the examples. The car trying to stop. And now we can use equation 3. And if we want to, we can go straight to the distance. Okay? Let's see. It's written on the formula, I think, 2v0 squared plus 2a delta x. So delta x equals v squared minus v0 squared. That was how it came out of the derivation anyway, over 2a. Okay, I still do have to realize that I stopped the car. So I have 0 squared minus the initial velocity squared, so 30 squared, divided by 2 times negative 6. It still does have to be negative 6. Okay, so delta x is 900 divided by 12. Can I do that in my head? Probably not. 75, I bet. Okay, it is 75. Okay, now, what's the point of that? Actually, now you can check on the test. You can check your work. So if you found the time, it does suggest to do that. These might be different questions that refer to the same setup, right? We might have question 1, 2, 3. They're all about this problem. Okay, now that you have equation 3, you can find the time, you can plug in the time to find the distance. You could go straight for distance with equation 3, but even if you solved it the other way, it's 50, you have 50 minutes, really almost 50, 48 for 20 questions. There's time to double check. And this provides a way to double check. You don't have to memorize this formula. It really helps so that it dawns on you to use it. But the formula is there. You can try to solve it a different way. Okay, without all this business of getting the time first. Okay. Any questions? Yes, sir. Absolutely. If you don't have the time and you want to solve for one of these other things, you don't need the time. You don't need to solve the time first. Maybe it helps. It's whatever you think. It's another option. It does, but I might not on the test. I might just give the setup. Okay, and so don't. Some people will get stuck because okay, we saw solving the time first. They'll get stuck trying to solve the time, like, oh, I need to know the time for this question, but I can't figure out what it is. I'm just blanking or something. You actually don't need it. So maybe, really, if you have complete information in physics, you could solve for anything you want. Okay? It's just a shortcut. But, as we're about to see in my favorite video, I think, when we're stressed out, when it's a test and it's a time crunch, it might not occur to you to solve the time. You may not have confidence in your answer of the time. Like, I solved the time, it doesn't ask for it, but I think I need it. I solved it, I don't know how to check. Okay, there's a way to check. There's more than one way to solve anything. Okay, and it's the same ironclad equations we got before. I'm sure I can do these. Okay, well, we wanted 50 meters per second, so we can use g equals 10. Okay. How high will the ball go? Okay. Delta y is v squared minus v0 squared over 2a. Okay. 50 squared minus, at the top, when it's at max, 0 squared over 2, oh, it's final. Flipped, I'm sorry. It's 0 squared minus 50 squared. Of course 50 is initial. Come on. Over 2 times negative 10. 50's up. It gets squared, then multiplied by negative 1. 2 is down. Okay, so 2,500 over 20, 125. Okay. And there's very little chance, if you mistake the negative sign on the acceleration, or even this negative sign, okay, as long as you know it goes in there, and that one's built in, right? If you forget a negative sign, you get a negative answer, which is actually impossible. If I hit it up, it doesn't end up back down. It collides with the ground first, but you'll still get the right number. You're right. Yeah, yeah, okay. How high will it go? Above its original. Okay. Yeah, yeah, yeah. That was the problem. But you get the point. Better. Okay. 126, yeah. Because it was initialization. Okay. I don't mean to redo the entire example. I just mean to show you that, okay, now you can get the distance straightforward. You don't need to know the time. Okay, if you had the change in distance and initial and final velocity, you could even actually, you could just solve, you could solve for acceleration, you could solve, whichever one is missing. And then you could go back and solve the time from there. No, if you do all the signs correctly, so when they're squared, right, there's parentheses in there. So when you're squaring velocities, you do ignore the sign because negative times negative is also positive. So those terms, a lot of people like this formula better because it's always minus on the top. Those two squared terms are always positive. It should be a negative acceleration because if 50 is plus headed up for the initial velocity, then acceleration is going down and it should be negative. Okay, yeah, so I forgot my negative signs here. It should be negative 2500 over negative 20. Okay, so it is correct. Um, but I think maybe once you get used to this one, less chance of errors. Okay, and if you make an error, it'll be obvious. Like it couldn't have wound up down. Okay, good. Any other questions? Oh, I use this formula way more, but for other reasons. We're not done with this one. We are for this chapter, but it'll be back. Okay, good. Any other questions? Okay, so anytime if you're given times in the problem, you should probably just plug in those times. But any instance where you're not given time, try equation 3 first. That's what it's for.